The Transrapid Magnetic Levitation Train, a brand new train concept, is the first to break through the limitations of wheel on rail. It makes train travel faster, environmentally friendlier, and more economic. The magnetic levitation train moves completely contact-free. The function of the wheel and rail on a railroad, the support and guidance, and the propulsion and braking is accomplished on the Transrapid through the electromagnetic levitation and propulsion system. Electronics are used instead of mechanics. Support magnets attract the vehicle from below to the guideway, while guidance magnets hold it laterally on the track. The support and guidance magnets are arranged on both sides along the entire length of the vehicle. An electronic control system ensures that the vehicle levitates at a constant distance of 3/8 of an inch to the guideway. This allows a ground clearance of almost 6 inches during levitation. Power is supplied to the levitation system and the onboard equipment by batteries. During travel, they are charged contact-free by the linear generators. Propulsion and braking are accomplished on the magnetic levitation train through a synchronous long stator linear motor. The motor is located not in the vehicle, but in the guideway. It functions on the same principle as a traditional rotating electrical motor, but with the stator cut, unrolled, and stretched lengthwise beneath the guideway. Instead of a rotating magnetic field, a traveling magnetic field is excited in the windings. And the vehicle is pulled along the guideway, contact-free. Along the guideway, only the motor segment in which the vehicle is currently traveling is powered. As the vehicle passes between 2 segments, the next one is automatically switched on, and the previous one is switched off. More power is installed on gradients and acceleration stretches than on level stretches. Propulsion energy is thereby particularly economic because it's only installed where it's needed. In other transportation systems, the vehicle always has to carry the full motor power. It's only used on a few stretches though, and otherwise is an unnecessary and wasteful load. The magnetic levitation train requires significantly less energy than a car or airplane, and it's also more economic than the already efficient modern railroads. The magnetic levitation train guideway is comprised of 165-foot-long steel or concrete beams. It can be run at grade or elevated and can be flexibly adapted to the given terrain. The guideway can be elevated where it makes ecological sense. The 15-foot clearance height doesn't cut up the landscape or existing structures. The area underneath can also continue to be used. The guideway can be run at grade where it is the more effective solution for reasons of acceptability or better noise protection. In every case, the magnetic levitation train guideway requires less ground and surface area than other transportation systems. The magnetic levitation train changes lanes by using a bendable steel switch. It consists of a continuous steel beam elastically bent by an electromechanical setting drive. The Transrapid can pass through the switch in the bent position at speeds of up to 125 miles per hour and in the straight position at full operating speed. Due to the active magnetic vehicle guidance on the guideway and the flexible propulsion performance, the magnetic levitation train has very favorable alignment parameters. curved radii are considerably smaller than the railroad, and its ability to climb 10% gradients is significantly larger. The Transrapid guideway can therefore be more easily adapted to the landscape. Contact-free technology is what makes the Transrapid so fast. A design for operating speeds of 185 to 310 miles per hour leads to trip times for middle and long distances, which were up to now only reserved for airplanes. To accelerate from 0 to 185 miles per hour, the Transrapid requires less than 2 minutes in a distance of 3 miles. Therefore, the Transrapid can be advantageously utilized on short stretches as well. Station stops and short intervals have minimal influence on trip times. The magnetic levitation train does not generate any motor or rolling noise. Therefore, one can hardly hear it at a speed of 125 miles per hour. The magnetic levitation train floats through cities and urban areas at this speed and is significantly quieter than a much slower suburban train. In a direct comparison of maximum noise levels conducted under the supervision of TÜV Rheinland, an independent testing organization, the following was measured 82 feet from the guideway. The result, for a locomotive-driven suburban train at 62 miles per hour, 91 dBA. For the Transrapid at a speed of 125 miles per hour, 79 dBA. And for a modern Berlin S-Bahn train traveling at only 48 miles per hour, 80 dBA. An increase of 10 dB is equivalent to a doubling of the noise level. Since the Transrapid's contact-free technology has inherently no wear, the noise level of the magnetic levitation train does not increase with time. This is also an important economic factor. Because of its low maintenance expenditure and its economic energy use, the operating costs of the magnetic levitation train are considerably lower than those of a modern high-speed railroad. Although the investment costs for the guideway are similar to a modern high-speed railroad track, they are lower for the Transrapid vehicle fleet. The smallest train unit consists of 2 sections. Each section has approximately 90 seats. Trains of up to 10 sections can be used depending upon traffic requirements. Neither the loading nor the train length has a bearing on the train performance. A special cargo vehicle is utilized for the transportation of up to 17 tons of goods per section. The magnetic levitation trains offer a high level of comfort. The contactless levitation and propulsion technologies guarantee absolute ride comfort. No jolting is felt. Passengers are not required to wear seatbelts, and they are free to move about the cabin at will. The magnetic levitation train is currently being prepared for revenue service at the Transrapid test facilities in Emsland. Independent appraisers from the German Federal Railroad and from leading academic institutes have, after thorough testing and assessment, approved the new train system's technical readiness for application. The Transrapid qualifies as the most significant innovation in ground transportation technology since the building of the first railroad. In only a few years, the Transrapid will be able to demonstrate its performance and environmental friendliness in everyday use.